Hello everyone, this is Vijayalakshmi Subnali from Enma's YouTube channel. Here in this session, we have to discuss the multiple choice based questions for PUC. Winmaths is a free YouTube channel helping students across Karnataka to excel in their PUC board exams and competitive exams. This channel helps to those who are studying PUC and guide you in making a PUC preparation well as well for various competitive exams. Okay, here we will discuss the questions first now. There is a first chapter sets. Okay, for us PUC, there is a first chapter sets. Here there is a first question. Which one of the following is not a set? We already know the definition of the set. Okay, that is set is a well defined. Okay, well defined collection of object. Well defined collections of object. Set means well-defined collection of objects. Okay. Here, which of the following is not set? Okay. Not set. First, a collection of all the months of the year beginning with the letter J. Okay. In a collection of months, there are 12 months are there. Okay. There are 12 months for a year. Here in this 12 months, the month name starts with the letter J. Okay. That is January. Okay. January starts with J. Next, January. Then June. Okay. Again, July. Only these three months are starts with the letter J. Okay. So we have to count easy. Okay. And whatever the count is there, only 3 months are there. Okay. This is also set. Next, the collection of all the boys in your class. Okay. Here, class means there limited students are there. Okay. In every class, there are limited. Your class means here, for example, in a first PUC science class, there are 80 students are there. Out of 80, some of them are girls and some of them are boys. We can easily calculate the boys number. Okay. So, this is also set, well defined. Then the collection of 10 most talented writers of India. Okay, here 10 most writers. Okay, 10 most writers. So many writers are there in India. Okay, for example, the writers in Kannada, Kuvempu, Masti Venkatesh Iyengar, and so many writers are there in English. William and Robert, so many are there. Again, in Hindi, so many Doha writers are there and so many writers are there. But we can't particularly the 10 most talented writers and not labeled in any 10 of them. Okay. So this is not a well defined. Okay. The collection of all natural numbers less than 100. Okay. We can take the natural number less than 100. That is 1 to 99. Okay. We can easily count the numbers. Okay. Therefore, the option C is not a set. The answer is option C. Second question. The set of intelligent students. Okay. How we identify the intelligent student? We can't identify the intelligent student. Best if we have to take an intelligent student, there are some circumstances are there. If he was wise students and ranker and so many, but ranker, the first place, not every time one student. Okay, so many students. If in a class there are, for example, there are 80 students. Are everyone should have their intelligence in own way. Okay, here we can't segregate one who is intelligent, who is not dull. Okay, that's why it is not a well defined. That is null set no. In a class, top students are there as well as average and below average. All those students are present. It is not a null set, singleton. Not anyone are intelligent. So many intelligent students are there. Otherwise, not okay. Finite. We can't count. If sometimes he was not well in health, that time he was getting less number in marks. But in another exam, he got good marks. That times we can't say. That is not a well-defined collection. The option number D is correct. The set x is a positive integer. In a number system, we have to collect the positive integer. That is positive numbers. X is a positive integer and x square is less than 30. For example, positive integer 1. 1 square is 1. 2. 2 square is 4. 3. X I have taken, these are the x values. Okay. Then here they given x square is less than 20. This one condition is x square. Okay. Here x is 1, x square is 1. X is 2, 2 square 4, 3 square is 9. Then x is equal to 4. Then 4 square is 16. Then x is equals to 5. That is 25. Then x is equals to 6. 6 square is 36. X is equals to 7. Then 7 square is 49. But they mentioned one condition, that is x square is less than 14. Okay. Here x square is less than 40 up to 36. Okay. Here we have to collecting the values of x are, that is 1, 2, 3, 4, 5, 6. Only these are the x values. In which option? Here 6 not there. This one is not. Okay. They given their squares. No. We want only x value because this one represent x. Here there is a x value. That x number should be a positive integer and their value x square is less than 40. So this is also not. The option number D is correct. For x values, we get the result less x square less than 40. The question number 4. The set A is equal to the elements 1, 4, 9, 16, 25 in a set builder form. Set builder form means we have to write in the X form or it is a general form. Set builder form means it is a general form. Okay. Here the numbers are like 1. It is the 1 square, 2. Here 2 square, 3 square, 4 square, 5 square, up to so on. So these numbers are the squares of the x. These numbers are the squares of x. So I can take x is a number. Then we have to take the x is equals to x square. The option number C is correct. The option number C is okay. Here this all conditions are not satisfied here. Next, question number 5. The set x is a prime number. Okay. Here we have to take the prime numbers. Okay. X is a prime number. What are the prime numbers? The numbers which is only divisible by that number or 1. Those numbers are called as a prime numbers. That is 2, 3, 5, 7, 11, 13, 17, 19 up to so on. These are the prime numbers. Here x is a prime number which is divisor of 16. Okay. Here x is prime number which is divisor of 30. Okay. 30 means first we have to take the values of the divisors of 30. Okay. 2 into 30 we get 60. Then in 3 table 60 presents and in 5th table 60 present and 15th. Okay. So next 60 is multiple of 52 is a 30. Then 4 15 4 is a 60. Next 2 30 is a and so many numbers are there. But they mention particularly it is a prime number. Without taking this problem, we can solve this one by taking the option method. Here they given x is a prime number, but 1 is not prime number. That and 2 is prime, 3 prime, but 4 is not prime. So I neglect the option directly. Here 1 they given 1 is not prime number, so I will discard the option B. Similarly, for C, 2, 3, 5. Okay, it is correct. Here 2, 3. But 5 is also divisor of the 16. That's why the option number C is correct. Next, the question number 6. The set X is a letter of the word mathematics. X is a letter of the word mathematics. So I can take the mathematics first. Yeah. Okay, this one I am taking. In a roster form, we have to write in a column. Okay. All the objects or elements or letters have to write in a column with a comma. Okay. By comma. And the words or objects not repeated. Not written twice or thrice. Okay. Here A. Then next T. H. E. M already is there. A is there. T is there. I. Next C. And yes. Matheics. I will check. Here M. This is not roster form because the letter we can write only once. Here Matheics. The option number B is correct. I will take comparing these two, both are same. That's why option number B is correct. The set X does not equal to X. This one is represents the null set. This one represents the null set. The elements not present in a set. Okay. X not belongs to X. That is null set. Then, which of the following sets are not disjoint? Here first, disjoint means if, for example, there are two sets A and B. Okay, there are two sets. Disjoint means not same elements present in both. Here the elements are different. Here the elements are different. That time we have to say A and B are disjoint set. Okay, otherwise not. A and B are said to be a disjoint set, and thus the elements of A is not present in B. Okay, that is called disjoint set. Here 1, 2, 3 and x is belongs to a natural number. X is greater than 4 and less than 6. Here 1, 2, 3. For this one set, I can take the elements. The value of x is greater than or is equals to 4. That is 4, 5, 6. Okay. I am saying these are the disjoint set because in set A contain 1, 2, 3 and the set B contain 4, 5, 6. Both there is no common elements between A and B. Therefore, it is a disjoint set. Okay. Here A, E, I, O, U and the set C, D, G, F. There is no common element between these two sets. That's why this is also disjoint set. X is a even integer and X is a odd integer. Odd integer means even integer. There is no common element. Okay. Even number means the numbers which is divisible by 2. The odd numbers means the number which is not divisible by 2. Okay. Then the odd and even, there is no common number between odd and even. This is also disjoint. The option B obviously the right answer. That is x is a positive prime number less than 10. Okay. The positive prime numbers less than 10, then there are 2, 3, 5, 7. These are the less than 10. X is a positive even integer. The element that is even prime number is 2. Here both 2 to present. That's why this is not a disjoint set. The option number D is correct. Then question number 9. If R is the set of real numbers, if R is the set of real number and Q is the set of rational numbers, then R minus Q. Okay, here R minus Q. R is a real number. Real means it contains both rational numbers as well as irrational number. Real number means it contains both rational numbers and irrational number. Here, real minus rational means we have to get the irrational number. That is the set of irrational numbers. Then A is subset of B. The question number 10. A is subset of B. Then the number of elements in A union B. A is subset of B means B is the larger set. B is the larger set. A is the smaller. Okay. A is the subset means B is the larger set. By using the B set, we have to write the A. Okay. From the elements of B set, we have to take or make the set A. That's why B is the bigger set, A is the small, otherwise it may be equal. Then the number of elements in A union B. While taking the A union B, this is the larger set and this is the smaller set. Okay, B is this larger and A is the taking from B. That's why the answer is B. A is subset of B. Then the number of elements in B. So the total number of elements in B is the number of elements in B are called the A union B. Let U is the universal set. Okay. Let U is the universal set containing 1, 2, 3, 4, 5, 6, 7, 8, 9. And the set A is contain 1, 3, 5, 7, 9. Then complement of set. Complement of set means other than the elements A which is present in universal set. Okay. The complement set of set A means other than set A, the elements which is present in U. Okay. Here 1. So I can neglecting the common elements. 1, 3, 5, 7, 9. So the left elements are there in universal set are 2, 4, 6, 8. These are the complement. 2, 4, 6, 8. And the option number D is correct. The number of non-empty subsets of the set. Okay. The number of non-empty. Non-empty means there are so many some elements present in that set. Okay. If we have finding the subset means we have to use the one formula 2 to the power n. N means the number of elements. The number of elements present in the given set. Number of elements present in a given set. That is called the subset. Okay. Here 2 to the power how many elements are there? 1, 2, 3, 4. 2 to the power 4. Okay. Here 2 to the power means have to multiply 2 4 times. 2 into 2 into 2. 2 to the 4, 4 to the 8, 8 to the 16. Okay. Here in this 16, there is they given the number of non-empty. Okay. Here every subset containing one empty set. Okay. Every subset is containing one empty set. Because empty set is the subset of universal or every set. That's why here I will minus 1. Okay. Because they given non-empty set. Because they ask only non-empty sets. That's why I will minus 1. Because this is the empty set. 16 minus 1 is 15. The option number B is correct. Next, A and B, any two sets. A and B are any two sets. Here, A intersection B, complement is. Okay. Here, we know the De Morgan's law. Okay. We know the De Morgan's law for complements. De Morgan's law. That is, A union B complement is equal to A complement intersection B complement. This is the first one, and another one is A intersection B complement is equal to A complement union of B complement. That's why by using the De Morgan's law, I can take the A intersection B complement, the second one. I can use the result second one. By the result of De Morgan's law, I directly write and the answer is option number B. A intersection B complement is equals to A complement union of B complement. Then the question number 14. Let A and B are two sets. Let A and B are two sets such that then is equal. If both are equal, then the answer is A and B are two sets such that when they both equal. Okay. If answer is null set. Okay. If A and B set does not containing any element, that time both the sets are equal. Question number 15. Okay. This is the very important rule. Okay. Here, if A and B are any two sets, okay, if A and B are any two sets, based on n of A represents the number of elements present in set A and n of B represents the number of elements present in set B. N of A union B, the number of elements present in A union B. Okay, like this. Here the result is n of A union B is equals to number of elements present in A plus number of elements present in B minus number of elements A intersection B. This is the true statement. This is the true statement. Here the number of elements A intersection B is equals to A intersection B is equal to number of elements A into number of elements B. Okay, this is not result because this is some cases are there, but actually this is the not true statement. This is not true statement. The option number C, number of elements present in A minus B means A minus B means okay, A minus B means the elements which is present in A only. The number of elements which is present in A but not B. A minus B means the elements which is present in A but not B. Here the result shows the number of elements A minus B means the only the number of elements which is present A but not B means there is no common elements between A intersection B. This is the true statement. Similarly for B, this is also true statement. The option number B is wrong statement. Okay. Next, question number 16. The set X such that here this is the intervals. The less than here the condition. The less than means strictly condition. Strictly less than. Here for strictly condition we have to use the open intervals. Open intervals indicates the strictly condition. Strictly condition. Here this one is open intervals. These open intervals represents the strictly condition. This is the close intervals. These columns are represents the close intervals. It may be less than or greater than. Less than or is equal to, greater than or is equals to, represented by the close interval. Here, for minus 5, there is a less than. Okay, there is a strictly condition there. So, for 5, we have to take the open interval. Here, less than or is equal to. That's why I am taking the close interval. The option number B is correct. I can easily neglect the option number C because the intervals are not written in a flower bracket. The intervals are not written in a flower bracket. That's why I can easily neglect the option number C. So the option number D is correct. Here, the question number 17. The x such that x belongs to R, a real number. 6 is less than x less than 10. Here between, here also there is a strictly condition. Here also strictly condition. For these two numbers, there is a open interval. Okay, there is a open interval between 6 and 10. The option number A is correct. The option number A is correct. Here x such that x is belongs to R, x is less than or is equal to 1. Okay, x is less than or is equal to 1 for this one. X is less than or is equal to 1. Okay, for this one condition, there is a less than or is equal to, we have to take the, in here only x present. That's why I'm taking the negative infinity. Okay, here negative infinity, I can take open interval. For this one condition 1, there is a close interval. The option number D is present. The option number D is present. Next, the intervals -7 and 12. Okay, for this one, so directly I'm taking x such that x is belongs to the real number. For this one, there is a close interval. So I can take -7 close interval, that is less than or is equal to x less than, because there is a open interval. So I can taking the strictly condition. This is the interval form. Sorry, na roster form. That is the option number less than or is equal to. The option number D is correct. Okay. Next, question number 20. The intervals 3, 8. Here the intervals between open intervals. The open intervals means both shows the less than. That is strictly condition. Here this the one is not. Both are less than or is equal to not. Here both containing strictly condition yes. According to the intervals, both are strictly condition. The option number C is correct. Next, question number 21. N of A is the number of elements which is present in A set. That is 10. The number of elements which is present in B set 6. The number of elements present in C set is equals to 5. For 3 disjoint set. Disjoint set means there is no common element between the any one of the sets. While taking the union of those two, all the equal sets. So I can add easily. Okay. N of A union B union C means the number of elements which is present in both the sets. Okay, I can take 10 plus 6. That is 16. 16 plus 5. 16 plus 5, 21. The option number A is 21 because here they mention disjoint set. Disjoint set means there is no common element between the any two sets. Next, the question number 22. Which of the following statements are incorrect? Every set is a subset of itself. Yes, it's a subset. Then null set is a subset of all sets. Yes, this is also correct statement. If B is a subset of A and B is not subset of A, then B is called the proper subsets of A. Yes, this is the proper subsets of A. Then if n of A, then the number of all possible subsets is given by. Here, every element, for example, n containing the A elements. Okay. Here, n containing the elements 6. For example, A be a set containing the elements 1, 2, 3, 4, 5, 6. Okay. Here, there are 6 elements. Then, the number of possible sets are 2 to the power 6. So taking the 2 to the power 6, 2 taking the 6 time multiplication. Okay, here 5, 6. 2 to the 4, 4 to the 8, 8 to the 16, 16 to the 32, 32 to the 64. There are 64 subsets are there. This is not true. Okay, this is the incorrect statement. The number of proper subsets of the given set containing the elements 1, 2, 3. Here there are 3 elements are there. Proper subsets means the number of subsets before. Finding the subset is have to take the 2 to the power n. N means the number of elements which is present in that set. Here 3. 2 to the power 3. Okay, 2 to the power 3 means multiply 3 times by 2. Here 8. But they given proper subset. Okay, proper subset means there is here, for example, A be a set and B be a subset. Okay, here A is said to the B is said to be a proper subset means B containing less than one elements of the A. For example, A containing 6 elements. By using the 6 elements, we have to take the B set less than 6 elements. Okay, less than 6 elements present in that set B, then we have to say B is a proper set. So here the proper subset means have to take the 8 minus 1. There is 7. Okay, the option number C is 7. If A and B are disjoint set, if A and B are disjoint means there is no common element between the two sets A and B. Then N means number of elements. A union B is equal to the number of elements present in A and the number of elements present in B. The option number C is correct. Question number 25. Which of the following sets are equal? Equal means the common elements present in both the set containing the same elements. But it may be changes in writing the order. Okay. Here for option A, 1, 2, 3, 4. Here also 3, 4, 1, 4, 1. Okay. Here 2 not present. This is not a equal set. 1, 2, 3, 4. Here 3, 2, 4, but 5 is there, 1 not there. So it is not a equal set. X is a multiple of 10. Okay. Here X is a multiple of 10 means the set A is multiple of 10 means 10, 20, 30, 40, 50 up to so on. Okay. Then set B contain 10, 15, 20, 25. These are not equal. Then X is a letter in the word follow. Follow means I can write in a roster form, that is F O. L two times are there. I can take 1 and O already written W. This is the set A. And the set B containing the elements the wolf. WOLF. There are same letters present in A and B. That's why A and B are equal set. The option number D is correct. Which of the following sets are infinite? Infinite means not taking or not easily taking or not counting. Okay. If whatever the elements not counting. Okay. Uncountable sets are called as a infinite. Here, while solving this equation, x minus 1, x minus 2 is equal to 0. We want the x values. So, equating the equation is equal to 0, we get x is equal to 1 and x is equal to 2. So, x has definitely two values. Here, solving the option number C, that is 2x minus 1 is equal to 0. We want x. That's why taking minus 1 on right side, it becomes 1. X is 1 by 2. This is also definite. Then finite. These are also finite. This is also finite set. X is a natural number and x is equal to prime. Okay. X is equal to natural number that S and x is equal 4. 4 is the only one element that is finite. The option number B is also finite. The option D, x is belong to natural number, x is a prime number. So there are so many prime numbers are there. That is 2, 3, 5, 7, next 11, 13, up to so on. This is infinite. This is infinite. Which of the following statements are incorrect? Incorrect means both are different. Here A comma B is subset of BCA. Yes, definitely it is true. Because AB, here also AB present, the AB is the subset of BCA. Yes, correct. AE, which is the subset of X is a vowel in the English alphabet. Yes, A and E are the vowels of the English alphabet. A, yes, this is also correct. But they given belongs. Okay. Here belongs means we can say in a set form. Okay. This is set. The set is not belongs to another set. So if we can take element A is belongs to A, B, C. This is the right form. Okay. But this one is not a set form. This is the incorrect. Okay. This is the incorrect. A is the subset of A, B, C. Yes, this is the correct statement. The option number C is the incorrect statement. Let A be a set containing 1, 2, 3, 4, 5. 3, 4 means the whole set containing, or I can take by representing one element that is called X. That's why the set containing the elements 1, 2, X and 5. Because there is a one flower bracket. The values 3, 4, I can take the values of X. Okay. 3, 4 belongs to A. No. Okay. Which of the statement is incorrect? Okay. Which of the statement is incorrect? Here 3, 4, which is subset of A. No. This is the incorrect statement. This is the incorrect statement. Because 3, 4, which is the 3, 4, I can take 3, 4 as a element. Element not represent in a set form. That's why this is the incorrect statement. 3, comma 4. I can take 3, comma 4 by x. X is belongs to set A. Yes, the statement is correct. 3, comma 4. Here 3, comma 4 means x. Okay. X is belongs to A. Yes, correct. 1 is the element which is belongs to set A. Yes, this is also correct, but the wrong statement is 3 comma 4. Next, question number 29. Question number 29. The number of elements has power set of A if A is equal to null set. Okay. Here power set means I can take the element, the subsets of the elements. Okay. Power set usually define the number of elements present in the subsets. Okay. Here A is equal to null set means there is no element in a set, that is A is equal to 0. The power set P of A, the number of elements in the power set is 2 to the power 0. That is 2 to the power 0 is 1. The option number A is correct. X is a set containing A, B, C, D and Y is equal to F, B, D, G. X minus means, X minus 1 means the element which is present in X but not in Y. Okay. First, we have to neglect the common elements between X and Y. What are the common elements? B and B. I can neglect it. And D, D. I can neglect it. So, X minus Y means the elements which is present in X but not in Y. The elements A and C. The option number C is correct. Which of the following statements are correct? The following statements are correct. 2, 3, 4, 5 and 3, 6 are disjoints. If the disjoint means there is no common element between those two sets. Okay. Here 3, 3 common is there. This is the incorrect statement. Okay. This is the incorrect. A, E, I, O, U and A, B, C, D are disjoint set. No. Here there is a common element between those two sets A. That's why this is the not disjoint set. 2, 6, 10, 14, 3, 7, 11, 15 are disjoint sets. Yes, there is no common elements between these two sets. This is the correct statement. The option number C is correct. I will check the option number D. 2, 6, 10. Okay, here also 2 present. Therefore, this is not a disjoint set. This is incorrect statement. Therefore, the option number is the C is the correct answer. Question number 32. If U is the universal set containing the elements A, B, C, D, E, F, G, H, then complements of set A, B, C. Complements of, here I can take U as a universal set, complement of complement. Okay, we already know the result. Complement of complement set is again a that set only. That's why I cannot take the problems directly, or I will take directly the elements ABC. Here the option number is also ABC. Okay, the option number A is correct. Let A, B and C be the sets such that A union B is equal to A union C. A union B is equal to A union C and A intersection B is equal to A intersection C. Okay. A union B is equals to A intersection C. It means if A union B, for example, A and B containing the elements 4, then A union C, both are containing the same elements 4. Okay. Then A intersection B is equal to A intersection B is equal to A intersection C. Means the same common elements are there. For example, between these two, there are 4 common elements. Here also 4 common elements. By these two results, I can say A is equal to, okay. Here, I can say A intersection B is equal to A intersection C. The option number D is correct. The option number D is correct. A intersection B is equal to, or else, okay, this is the correct statement. Which of the following examples of the null set? Which of the element is the null set? The set of odd numbers less than 3. That is 1. The odd numbers containing less than 3 is 1. Set of even prime numbers, that is 2. X is a natural number between 5 and 7. There is a element 6. Y is a point common to any two parallel lines. For example, I will consider these two lines. There is no common between a point between these two lines. Parallel lines are never joined, or they can take the together, but they can't never uh, cut any one line. Okay, the option number D is correct. This is the example of the null set. The power set of A, the power set of A, that is power set, there are two elements. The power set is, the main first set is, every set is itself containing the empty set, and A comma B. This is same set B, the power set, set A and set B. There are 4 sets are there. The option number C is correct. The number of subsets of set is 16. Then the number of elements in A is the question number 36. The number of subsets of set is 16. Okay. Then the number of elements. For here, 2 to the power n is equal to 16. Because the number of subset, for example, finding the number of subsets is 2 to the power n. 2 to the power n is equals to 16. Now, I can take 16 can be written as 2 to the power 4. 16 can be written as 2 to the power 4. So, I will take here 16. I will taking by 2. 2 8s are, then taking 2 4s are, then 2 2s are, 2 1s are. So, while multiplying 2 by 4 times, we will get 16. So, 16 can be written in the exponent form 2 to the power 4 by using the law of indices. If bases a to the power b and a to the power c, if bases are equal, then the exponents are also equal. Bases are equal, then their exponents are equal. Therefore, n is equal to 4. The option number A is correct. Question number 37. If A has a 4 elements, then the number of subsets of A here 2 to the power 4, that is 16. This is the answer. Option number B is correct. If set A has a 3 elements, the number of elements in power set, that is 2 to the power 3. 2 into 2 into 2. 2 to is 4, 4 to is 8. The option number B is 8. Next. Okay. Question number 39. Question number 39. The set builder form. The set builder form, the elements 3, 6, 9, 12. 3, 6, 9, 12. Okay. Here x is a multiple of 3. Okay. This is also correct. But here x is a multiple of 3. 3, 6, 9, 12. It is a definite or countable, but x is multiple. So many are there, 15, 18, 21, 24. But generally, it is not true. This is not. X is a prime number. No, 6 is not prime number. X is a multiple of 3x greater than 4. Here, no, this is also wrong. Here we can take the x value 1, 3 into 1. But greater than 4 means so many elements are there, 5, 6, 7, up to so on. X is a multiple of 3 and 1 is less than x less than 4. Yes, 3 ones are 3 and 3 fours are 12. The values of x between 1 and 4. The option number D is correct. Question number 14. The roster form of the set A. The roster form of the set A is equal to x such that x square plus x x square plus x minus 2. X square plus x minus 2. Here, I will take the values x square, roster form. Okay. Here, I can take the values x is equal to 0. X is equal to 0. You will get x square plus x minus 2. While taking the x value 0, 0 plus 0, I will get minus 2. Similarly, x is equal to 1. Okay, x is equal to 1. 1 square is 1 plus 1 minus 2. I will get 0. X is equal to 2. X is equal to 2. Then 2 square is 4. 4 plus 2. 6 minus 2. 4 plus 2. Here 2 get cancelled. There is a 4. From minus 1, 0, 4. Okay. The roster form of the set A, x is x square plus x. From minus 1 to 1. Because while taking the values here, when I will take the x is equals to 0, then we will get the values minus 2. After that, we will get the positive values. The option number B is correct. The option number B is correct. Then question number 41. The set builder of the interval. The set builder of the interval. Here there is a open here there is a open interval. So consider the strictly condition. There is a closed interval taking less than or is equal to. Here both are less than, so I will neglect it. Both are less than or is equal to condition. I will neglect less than and less than or is equal to. The option number C is correct. Here, U is the universal set. The question number 42. If U be the universal set containing the elements 1, 2, 3, 4 up to 10 and A be a set containing 1, 3, 5, 7, 9, then A canon, A complement. The complement of A set, that is the common element taking other than A. The elements which is present A other than in universal set. Therefore, A complement. Here 1 is there, so I will neglect 2. 3 is there, so I will take 4. 6, 8, 10. Okay. Up to 10, the elements 2, 4, 6, 8, 10. Option number D is correct. If set A has a n elements, then the number of elements in power set. Okay. If set A has a n element, the number of elements in power set is 2 to the power n. The option number A is correct. Up to this much, I will cover all the multiple choice questions for set chapter. Okay. If you have any doubt, please write your doubt on comment box. I will solve. Okay. If you have any doubts, please write in a comments box. Otherwise, if you really like my channel, please press like button. If you are not subscribed till, so please subscribe my channel and support me. Thank you.